Hi, in this video we introduce the idea of complex numbers. So a complex number, first off, is a number written in the form a plus ib, where a and b are both real numbers. So imagine that I take a real number and I add it to an imaginary number. This number, the sum of a real number and an imaginary number, is what's called a complex number. So we can look at what happens with complex numbers when we perform our regular arithmetic operations. So here it says to simplify, and I've got 3 minus the square root of negative 24. Well, if I want to simplify this, I can actually reduce this radical, the square root of negative 24. I can rewrite this as 3 minus the square root of 4 times the square root of 6 times the square root of negative 1. Now, the square root of 4 is just 2, so I've got 3 minus 2. The square root of 6 can't be reduced any further, so I just have 3 minus 2 root 6. The square root of negative 1 is just I, so I can rewrite this as 3 minus 2 root 6i. In b, I've got 10 plus the square root of negative 32, all divided by 2. So I can rewrite this as 10 plus the square root of 16 times the square root of 2 times the square root of negative 1, all divided by 2. Now, this simplifies because the square root of 16 is just 4. So I get 10 plus 4 times the square root of 2. The square root of negative 1 is just I. So I get 10 plus 4 square root 2i, all divided by 2. Now let's think about if there's a way to write this a little bit nicer. Well, 10 and 4 are both divisible by 2. So I can common factor out of these two terms. I can common factor out a factor of 2. And I can write this as 2 times 5 plus 2 square root 2i, all divided by 2. Now, if I were to distribute 2 into the bracket, I should get the same expression back. Or I should get the same number back, rather. 2 times 5 is 10. 2 times 2 is 4. So if I distribute 2 to each of these two numbers, I'll get 10 plus 4 root 2i. So all that I've done is I've just done a little bit of common factoring. Now, I've got 2 times this complex number divided by 2. The inverse operation of multiplication by 2 is division by 2. So I can actually divide out this factor of 2. And I'm left with 5 plus 2 root 2i. So this simplifies to 5 plus 2 root 2i. In this next example, I'm asked to add 6 plus 2i minus 4 minus 8i. So remember that for our complex numbers, I have to be able to apply the rules of arithmetic in the same way that they apply to the real number system. Our operations have to be consistent. So first off, there's no operation outside of the brackets to 6 plus 2i. I can really think about this as just distributing 1 into 6 plus 2i. So immediately I can get rid of the brackets. So I get 6 plus 2i. Now I've got minus bracket 4 minus 8i. So I can use the distributive property, and I can distribute negative 1 to both of these terms. So this is equal to 6 plus 2i minus 4 plus 8i. Well, 6 minus 4 is just 2. 2i plus 8i is 2i plus 8i should give me an imaginary number, so I get plus 10i. This is a complex number. I can just leave it as 2 plus 10i, where it has both a real part, 2 is the real part, and 10i is the imaginary part. So this is a complex number. Next, let's look at a product of, let's look at a product of two complex numbers. So here I've got, in D, I've got 4 minus 3i times 2 plus I. Well, here we have to use FOIL, because I can think about this as the product of two binomials. So in order to expand this product, I'm going to multiply 4 times 2, and then I'll add to that 4 times I, and then I've got to do the inner product, which is negative 3i times 2 and negative 3i times I. And then I add those products, essentially. So I have 4 times 2 is positive 8. 4 times I is positive 4i. Negative 3i times 2 is minus 6i. And negative 3i times I is equal to minus 3 times I times I. And let's see what this simplifies to. Well, here I have just 8 plus, well, 4i minus 6i is 4i plus, or sorry, 4i minus 6i is negative 2i. And then I have minus 3i times I. Well, let's think about what negative 3i times I is. I times I is negative 1, so I've got negative 3 times negative 1. And now this product is actually real. So I've got 8 minus 3 times negative 1. Well, 8 minus 3 times negative 1 is 8 plus 3, because I'm subtracting a negative number. 8 minus 3 would be 8 plus 3, which is 11. So this simplifies to 11 minus 2i. And you can see that when I expand this product, I still get a complex number. I get a number that has both a real part and an imaginary part. So in this next example, we're going to expand, we're asked to expand 2 plus ai times 2 minus 3i. And then it asks, what must a be to make this product real? So this is an interesting example. Well, let's first go ahead and do what the question says. It says to expand 2 plus ai times 2 minus 3i. So we have 2 plus ai times 2 minus 3i. And if we expand this using FOIL, well, we get 2 times 2, which is 4, 2 times negative 3i, which is minus 6i. Then we have plus 2 times ai, which is 2ai. And then we have plus, actually we should get minus a times 3 times I times I. So a times 3 times I times I. And if you're wondering how I got that last term, well, I just multiplied ai times negative 3i. So when I do that, I get negative a times 3 times I times I. Now, we can do a little bit of simplifying here. Let's see here. I get 4 minus 6i plus 2ai. And this last term, I've got I times I, which is negative 1. So I'll have minus a times 3 times -1, which is the same as adding 3a. So we said that a is, I should have said here that a is a real number. So a is an element of the real numbers, or a is just, assume here that a is a real number. And we're going to say, what must a be to make this product real? So here, notice that the only imaginary, the imaginary part of this number comes from these two middle terms. So it's, if we want to figure out what a must be to make this product real, well, I would say, okay, what value of a makes this sum add up to 0? Well, notice that if a is positive 3, then I would have, for the middle term, I'd have, let's see here, let me write this in red. I would have -6i plus 2 times 3 times I, which would be equal to -6i plus 6i, and that would be equal to 0. And then the number here would be, the product would be 4 plus 3 times 3, because a would be 3. So 4 plus 3 times 3, which is 4 plus 9, which is equal to 13. So if a were equal to 3, I would get that this product would be equal to 13, because the middle terms would add to 0, and I would have no imaginary part. I would have a number that's just real. So anytime, notice that if I actually input 3 for a, I would get that this product would be 2 plus 3i times 2 minus 3i. And notice that these are actually conjugates. So I have 2 plus 3i times 2 minus 3i. And the product of conjugates always results in a difference of squares. So that's not a fluke. If you multiply two complex, these are called complex conjugates. Complex conjugates. Oops. Anytime you multiply complex conjugates, you'll always get a real number. And we'll look at that in more detail in the next lesson. So that concludes this video, and we'll see you in the next lesson.